Okay, in this unit of work we're going to sketch graphs that involve things called asymptotes. You should have seen this graph before at GCSE. This is known as the reciprocal graph. Okay, and this has two asymptotes. It has an asymptote along the x-axis and along the y-axis. Okay, so what is an asymptote? Well, this graph here will tend towards the x-axis, getting closer and closer and closer, but will never cross. Okay, so the idea of tending towards a value but never meeting that value is what an asymptote is. So as x tends towards plus infinity, this graph tends towards the x-axis, or y equals 0, and when the graph tends towards minus infinity, it also tends towards 0. We have another asymptote here. So as x tends towards 0 from the positive direction or from the negative direction, they both tend towards this vertical asymptote, which is the asymptote x equals 0. So what we're saying, looking at this vertical asymptote, is that we're saying when is y not defined? In other words, when is there not a possible y value on this graph? So when does this graph not cross the x-axis? So if you think about it in terms of this equation, we're saying when is y not defined? I.e. when can I not find a corresponding y value? And we can see that it's when x equals 0. So if we put that in there, we get alarm bells. Yeah, not happy about that. So to find vertical asymptotes, we say we're going to make my denominator equal 0. If I make that equal 0, I can't solve for y. Y is then undefined, therefore the asymptote exists. So a quick example, if we had, alright, how would I find the vertical asymptote? Well, we're saying when is y not defined? That means when does my denominator equal 0? And you can see that's when x is minus 6. Okay, so we know that this has a vertical asymptote when x equals minus 6. So if we sketch this graph, that means that that reciprocal graph has actually been shifted. This is my new asymptote, which we denote with a dotted line. So that was, in the reciprocal graph, just the y-axis. So it's been a shift 6 units to the left. So if you carefully draw in your graph, that's what it would look like. Now when you go on to look at graph theory, graph transformations later, you will understand how this shift to the left leads you to this equation. To find the vertical asymptotes of this graph, alright, so when is y undefined? When the denominator equals 0. So for what values of x does this equal 0? So if we factorise, we'd get x minus 3, x plus 2, giving me x equals 3 and x equals minus 2. Okay, now we're not doing the full sketching process now, but when it comes to it, at that stage there, you can mark on your vertical asymptotes with your dotted lines and then go from there with the rest of the process. Okay, so we're going to look at finding the horizontal asymptotes for a graph. So what this is, we're looking at the extremes. So we're looking as x tends towards infinity, as x tends towards minus infinity. What do they converge to? In this example, as x tends towards plus infinity or minus infinity, our graph tends towards the x-axis, so y equals 0. So we're saying what happens as x tends towards plus or minus infinity. The best way to show you the method, I think, is with an example. So we're going to find the horizontal asymptotes for the graph y equals 6 plus 2x all over 3x plus 4. Okay, the method that we use is we look for the highest power of x involved in our equation. We're going to divide each term by that. So it's a single x to the power 1. Okay, so if I divide each term by x, we can then look at each term individually and see what happens in this scenario. So if I look at the 6 over x and the 4 over x, as x tends towards plus or minus infinity, so the number's getting infinitely large, okay, the larger the number on the bottom of a fraction, the smaller the fraction. So we can say as x tends towards plus or minus infinity, these both will tend towards 0. They will get smaller and smaller and smaller and smaller. This enables us to ignore those. Then, look at these terms I've got left. Well, my x's will cancel there, my x's will cancel there. So I am left with 2/3. So what we're saying, as x tends towards plus or minus infinity, y tends towards 2/3. So if we were to draw that, we would draw our asymptote at 2/3. And as my graph tended towards infinity or minus infinity, my graph would tend towards 2/3. We'll go into how we're going to draw the graph later on when we do sketching, but for now we're just looking at where the asymptote would be. Okay, so hopefully you've had a go at the example in your workbook, so we'll just work through the solution. So the first thing to spot, again, what the highest power of x, and we'll divide through by that. So, excuse me, minus. Alright, so let's look at the terms. So, we're looking for these terms first, the terms with the x just on the bottom. So 4 over x and 1 over x will tend towards 0 as x tends towards plus or minus infinity, enabling us to forget those. What's left? Okay, my x's cancel there, my x's cancel there, leaving me with a 1. So don't forget your minus, we end up with minus 2 over 1, so minus 2. So that tells me that when I'm going to come to sketch, I'm going to draw my horizontal asymptote at minus 2. Right, we're going to refer back to the question I used earlier, and we're going to sketch this graph completely. So our step 1, which we're going to look at now, is you find asymptotes. So, how did we find the vertical? We can abbreviate that to VA. We said it was when the denominator equals 0, so we can rearrange that to get x equaling minus 4/3. To find the horizontal asymptote. Okay, now the way we wrote it out before, there's not a problem with that mathematically. That's more sound, you're explaining what you're doing. But in the exam scheme of work and in the exam mark schemes, you won't get marks for that. So there is a trick, there is a quicker way. So we look at the power of x. We're going to divide each of these terms through. We can see that 6 over x and 4 over x, as we mentioned earlier, as x tends towards infinity, they would both disappear. So it would leave me with 2x over x, x is cancelling to give 2, and 3x over x, x is cancelling to give 3. So we would get y equals 2/3. Okay, so if we sketch those onto our graph, and it's a sketch, so as long as you label it correctly, approximate positions are fine. So that's x equals minus 4/3, and then we've got y equals, oh, excuse me, don't need to do that, 2/3. Make that look dotted. Okay, step 2 in the sketching process is going to be find crossing points. Finding crossing points when sketching is fundamental to all graph sketching in maths, and if it's something you've got a weakness with, it's something you really need to work on. It comes up in all units in your Core 1, your Core 2, all the way through to your FP1 and your FP3 that you'll be studying. Okay, so crossing points. So where does my graph cross the y-axis? Where does it cross the x-axis? Well, we know when my graph crosses the y-axis, what do I know about the value of x? Well, x will always be 0. So when x equals 0, so subbing into my graph, I'd get 6 plus 2 lots of nothing, which would give me 6. 3 lots of nothing plus 4 would give me 4. Okay, we can simplify that down to 3 over 2. So I know that when x is 0, it crosses at 3 over 2. So let's mark that somewhere up there. And label this in red so we can see the difference, not confuse those two. Okay, so then where does it cross the x-axis? So that is when y equals 0. So if I substitute y equals 0 in here, imagine multiplying up by all of that, it just disappears. So what we're saying is we're looking for the solution when 6 plus 2x equals 0. So that would give 2x equal in minus 6. So x would be minus 3. So let's mark that on our graph. So when y is 0, x is minus 3. Okay, we can have a good idea of the shape of the graph now. It's going to tend to 2/3 when x tends towards plus infinity. It's going to cross here and it has a vertical asymptote there. And then just carry that on a bit, we can see here it would cross here and it would tend towards those two asymptotes. Okay, so there is your graph of y equals 6 plus 2x all over 3x plus 4.